Today I want to do proof by induction for the derivative of x to the nth power, which is the power rule. So we know that its derivative is going to be n times x to the n minus 1. Now with induction we have to do the base case. So we have to prove the derivative with respect of x to the first power is equal to 1 times x to the 1 minus 1, which is going to be equal to 1x to the 0, which is finally just the value 1. Now we know this to be true because the derivative is going to be the slope of this line, and the slope of x to the 1 is going to be its coefficient, which is x in front of here, so this is equal to 1. We could also verify it with the difference quotient and taking the limit as h goes to 0. So we verified it works for 1. So the second thing, we're going to assume this works for some m. So assume m. What that means is the derivative with respect to x of x to the m will be equal to m times x to the m minus 1. Now we have to verify it that it works for 1 bigger. So what about the derivative with respect to x of x to the m plus 1? You know, if this follows this rule, then our proof is done and this is verified. So we know that this is going to be equal to the derivative with respect to x of x to the m times x to the 1. And I'm going to go ahead and use our product rule. So this is going to be equal to the derivative with respect to x of x to the m, derivative of the first, times the second, plus the first, times the derivative of the second. Now we know the derivative of this, using this assumption, is going to be equal to mx to the m minus 1 multiplied by x plus the derivative with respect to x of x, which is just going to be 1 times x to the m. So this is going to be equal to this. Now distributing this x over is going to make this power go up by 1. So this would be equal to mx to the m plus x to the m, which is going to equal, since they both share an x to the m, this is going to be equal to m plus 1 x to the m power. Verifying that this actually works, because what we've done is we've taken the power, put it out front, and dropped it by 1. Please subscribe.